All right, so we have spent a couple of days now solving one-step equations. So I think it's time now to kind of build on that. And so today we are going to be doing two-step equations. Now, you'll remember that when we did the one-step equations, they got their name from the fact that they had one operation in them. So they either had an addition, a subtraction, a multiplication, or a division, one of those. And we had to undo that one operation by doing the opposite operation. Now, two-step equations are going to have two operations in them. Two operations in them, and you're going to have to undo both of those. So here's what will happen. You will have one addition or subtraction in the problem, and then one multiplication or division. So in a two-step equation, you'll always have that. You'll have either an add or a subtract in the problem that you'll have to undo, and then a multiply or a divide in the problem that you'll have to undo. Okay? Now, with two-step equations, we're going to follow our same equation rules. The same four that I've written up twice now for you. We're going to draw the line through the equal sign to show the two sides. We're going to remember that whatever we do to one side, we're going to do the same thing to the other. We're going to remember that to undo something, you do the opposite operation. And then finally, we're going to remember that the goal is to get the variable by itself. Now, here is the kind of new part of that. We're going to add on to two-step equations. I've already told you you're going to have either an addition or a subtraction in your problem, and then a multiplication or a division. And it matters what order you undo those. So when you're doing a two-step equation, the first thing I want you to do is undo the addition or the subtraction first. So we're either going to add or subtract first when we're solving a two-step equation. And then the second thing I want you to do is undo either the multiplication or the division. So in two-step equations, look for adding or subtracting first and undo it first. Then look for multiplying or dividing last and undo it last. And we're going to talk about that as we go through our examples here. But don't forget those other four equation solving rules that we've talked about several times now. All right, so let's look at our first two-step equation. We're going to solve 3x plus 6 is equal to 18. 3x plus 6 is equal to 18. Now, we are going to draw our line through the equal sign like we always do. And we are going to get our eyes on that x because we know what we want. We know we want him to end up alone. Now, I want you to remember what we said here. We said that a two-step equation would have two operations in it, two things that are happening to x. Okay? So what are the two things you see here? Well, when you see 3x, what does that mean you're doing to x? Right, that means you are multiplying by 3. And then we see this plus 6, so we are adding 6. So there are two things we have to undo now. We have to undo multiplying by 3, and we have to undo adding 6. And remember what I told you. You're going to undo adding or subtracting first, and then undo the multiplying or dividing last. So to help us with that, here's what I'm going to suggest you do. Okay? I'm going to suggest that you start out by covering up the term that has the x so that you can clearly see you're adding or you're subtracting. So notice that when I cover up that term that has the x in it, I can clearly see now that this problem has adding 6. I have to undo that. So how do I undo adding 6? Well, I do the opposite, which is to subtract 6. My adding 6 and my subtracting 6 cancel each other out. All right, now that I've taken care of that, I'm going to take my little rectangle away that I used to cover that x term up. So I want you to notice that on this side, I have 3x. And on this side, I have 18 minus 6, which is 12. So I have a new equation. It's not solved yet because x isn't alone, but I'm closer now. I'm closer to having x alone. My plus 6 and my minus 6 canceled each other out. So now I have 3x on this side, 12 on this side. All right, so now, when I look at my equation, what's happening to that x? Well, I can see that my x is being multiplied by 3. So now I need to do the opposite of that. So the opposite of multiply by 3 is divide by 3. So I'm going to do that on both sides. My multiply by 3 and my divide by 3 cancel each other out, so now x is alone, and then 12 divided by 3 is 4. So look for your adding or subtracting first and undo that with the opposite. And then look for your multiplying or dividing last and do the opposite. So this problem had adding 6, I subtracted 6. It had multiplying by 3, I divided by 3. Okay, so next up, let's look at this problem. 5x minus 3 is equal to 12. Draw your line through your equal sign. Think about your x. You want to get him alone. Think about what's happening to him. Well, I see 5x. That means I'm multiplying x by 5. And I see minus 3, so I'm subtracting 3. So I want you to notice, I have to undo multiplying by 5 and subtracting 3. All right, so the first step is we are going to cover up this term that has the x, so we can see whether we are adding or subtracting. We're always going to undo adding or subtracting first. I see minus 3. I see subtracting 3. So I do the opposite and I add 3, remembering that I've got to do that on both sides. All right, so my subtracting 3 and my adding 3 are going to cancel each other out. Now that I've done that, I can take this square away. And so I have now 5x on this side, and then 12 plus 3 is 15. So I have undone my subtracting. Now I'm going to look at this for multiplying or dividing. When I see 5x, I know that means 5 times x. So this is multiplying by 5. So now I'm going to undo that multiplying. To undo multiplying by 5, I divide by 5. So my multiplying by 5, my dividing by 5 cancel each other out, leaving x alone. 15 divided by 5 is my answer, which is 3. So I end up with x equal to 3. So we look for the adding or subtracting first and undo that. And then we look for the multiplying or dividing last and undo that. All right, 7x plus 12 is equal to a negative 23. Draw your line through your equal sign. And we're going to undo addition or subtraction first. So we're going to add or subtract first. So I would cover up that x term so you can see what you're dealing with. You can see you're dealing with adding 12. Adding 12. So we want to get rid of adding 12. Do the opposite, which is to subtract 12. Adding 12, subtracting 12, cancel each other out. All right, now uncover that x and let's see what we've got. We have 7x on this side equal to negative 23 minus 12, which is a negative 35. All right, now I'm looking at that 7x. I know that means 7 times x, so I see multiplying by 7. I need to do the opposite. So I'm going to divide by 7 on each side. Multiplying by 7, dividing by 7 cancel each other out. X is alone now. Negative 35 divided by 7 is a negative 5. So I want to point out we've done 3 examples. They all follow the same pattern. You cover up that x and kind of ignore him to see if you're adding or subtracting, and you do the opposite. And then once he is uncovered, you look at whether he's being multiplied or divided, and you do the opposite. So it's add or subtract first, multiply or divide last every single time. So get yourself in that mindset when you're doing a 2-step equation. First, look at the equation to see if you've got to add or subtract. Then look at your equation to see if you need to multiply or divide. All right, now, this is the point again where I think what we need to do is start kind of rearranging the equations to show you that no matter how they write them, if you'll follow those same steps, you're going to get the right answer. So 8 plus 5x is equal to 13. Draw your line through the equal sign. My first step is going to be to undo addition or subtraction. So I am going to cover up my variable term. So I'm looking at that 8. Is that adding 8 or is that subtracting 8? Is that adding 8 or is that subtracting 8? This one's kind of weird because the plus sign comes after the 8. Let me tell you how you're going to know. Look at that 8 and think about whether he is a positive 8 or a negative 8. Look at that 8 and think about whether he's a positive 8 or a negative 8. How do we know? Well, we know because when we look in front of him, we don't see anything. And when we don't see anything in front of him, we know he's a positive. So I'm going to put a plus there. So that is adding 8. He is a positive 8, so that is adding 8. And I've got to undo that. So I do the opposite. The opposite of adding 8 is subtracting 8. And I have to do the same thing to both sides. So I want you to notice that my adding 8 and my subtracting 8 are going to cancel each other out. Now, let's take that cover away so we can see where we are. Well, on this side, we have 5x. And on this side, we have 13 minus 8, which is 5. All right, now that that x is uncovered, I'm going to do the second step, and I'm going to undo multiplying or dividing. Well, what do I have here? Do I have multiplying or dividing? Well, this is 5x. This is 5 times x, so I have multiplying by 5. So I will do the opposite and divide by that 5. So my multiplying by 5, my dividing by 5 cancel each other out. I have x alone, and my answer over here, 5 divided by 5, is equal to 1. So first, notice every single time I look for adding or subtracting, and I undo that first. I'm covering up the variable to help me do that. And then I look for multiplying or dividing second and undo that. So add or subtract first, multiply or divide last. Every single time. All right. Take a look at this one. Negative 8 plus 7x is equal to a negative 22. Draw your line through your equal sign. Draw your line through your equal sign. We are going to look for adding or subtracting first. So to help me with that, I am going to cover up my variable. Now I want you to notice what I have over here. I have minus 8. I have negative 8. So is a negative 8 like adding 8 or subtracting 8? It's like subtracting, right? A negative is like subtracting. So I want you to see this as subtracting 8. Subtracting 8. And you have to undo that. So to undo subtracting 8, you add 8. So always we're in that mindset of do I have adding or do I have subtracting? And whatever you have, you do the opposite. So this is subtracting 8, I add 8. Subtracting 8, adding 8, cancel each other out. All right, so uncover. You now have your 7x, and that is equal to negative 22 plus 8, which is a negative 14. So now that the x is uncovered, I can go after that 7. And when I see 7x, I know that means 7 times x. So this is multiplying right now. So I need to do the opposite, which is divide, and I'm going to divide by that same number. So I'm going to divide by 7. Remember how we talked about don't change the number, change the operation he's doing. So when you see the 7 is multiplying, divide by that same number, that 7. So the multiplying by 7, the dividing by 7 cancel each other out. You have x alone. Negative 14 divided by 7 is a negative 2. You've done this before, so I'm hoping this is all coming back to you as we do these examples. Next up. Now this one I want you to pay extra special attention to. You have 16 minus 3x is equal to 34. I want that line drawn through that equal sign. We're going to go after adding or subtracting first. So to help us focus on that, we're going to cover up this variable term. Now, here's what I need you to do. That minus sign, notice, it's 16 minus 3x. So the minus belongs to 3x. I want you to look at that 16, and we need to think about whether that is adding 16 or whether that is subtracting 16. Because right now, remember, I'm in addition-subtraction mode. So in front of him, I don't see anything. That means he's a positive. So that 16 is like adding 16. So to cancel them out, we're going to subtract 16, each side. Look for adding or subtracting, undo it first. So your add 16 and your subtract 16 cancel. Now, here's where I need you to pay extra special attention. When I remove the cover from the variable, I want you to look at what we have there. It's not 3x, it's negative 3x. That minus sign stays with him and makes him negative, so that's negative 3x. And that's equal to 34 minus 16, which is 18. So we've undone our addition with a subtraction. Now we're looking at negative 3x. That is multiplying. That is multiplying. We are multiplying by a negative 3. So we need to do the opposite, which is to divide by negative 3. Don't change the negative 3. Change the operation. He's multiplying, so you divide. So you're multiplying by negative 3. You're dividing by negative 3. Cancel out. X is alone. And on this side, you have your answer. 18 divided by negative 3 is, whoops, a negative 6. A negative 6. Don't know what I was doing there. Let me erase that and make that right. So x is equal to a negative 6. So I want you to notice, no matter how they rearrange these problems, solving them is the same. We cover up the variable, and we undo addition or subtraction that we can see. And then once that variable is uncovered, we undo the multiplication or division. Now, on this last one, let's draw a line. We have 26 is equal to a negative 18 minus 11x. I'm going to start in this two-step equation by covering up my variable, so that I can focus on addition or subtraction. So my number that's uncovered is a minus 18. So that is subtracting 18. So I'm going to do the opposite. I'm going to add 18. If I do it on one side, I have to do it on the other. My subtracting 18, my adding 18 cancel each other out. So now I can take away this cover and work some more on this problem. 26 plus 18 is 44, and that's equal to, on this side, now be careful here, because notice there's a minus in front of him, so that makes him a negative 11x. All right, now that variable is uncovered, time to multiply or divide. I look at this, and when I see negative 11x, I know that means I'm doing negative 11 times x. This is multiplying. So I will do the opposite and divide by negative 11. Don't change the number, change the operation. So negative 11 multiplied up here. Let me back up and try this again. Multiplying by negative 11, dividing by negative 11 cancels each other out. So x is alone over here. My answer is on this side this time. 44 divided by negative 11 is negative 4. So I end up with negative 4 equal to x, where x is equal to a negative 4. All right, so two-step equations. There will be one addition or subtraction in the problem. You need to cover up the variable so you can see it and cancel it out first. Undo it first. Then, once that variable is uncovered, you will see a multiplication or a division. And again, you will undo it by using the opposite operation. So always remember be in that addition or subtraction mode first, and then multiplying or dividing. You will work on this today and tomorrow, so Thursday and Friday for this week. So if you're having trouble, let me know. On Friday, when you're working on the problems, rewatch this video, rewatch these examples if you need it. But I'm counting on you to let me know if you got any questions whatsoever. Solving equations is an important skill, not just for this year, but for all of the math that you'll take in high school. So let me know what I can do to help.